Okay, now let's look at example 2. Use the rational root theorem. A storage company is designing a new storage unit. Based on the dimensions shown, the volume of a container is modeled by the polynomial v of x is equal to 2x cubed minus 7x squared plus 6x, where x is the width in feet. What are the dimensions of the container in feet if the volume of the unit is 154 feet cubed? So we have the dimensions in variables, right, in polynomials. So we have x and 2x minus 3 and x minus 2. Those are the dimensions. And if we multiply the dimensions, we'll get the volume, right? The volume we know is 154 feet cubed. So find the solutions to this equation. 2x cubed minus 7x squared plus 6x. If we multiply all of them, we get this volume equation, right? The zeros of the polynomial will be rational roots of the equation in standard form. Yeah. So first, list the factors of the constant term and the leading coefficient. So from this equation, based on the equation, we can look at the constant term and the leading coefficient to figure out the possible roots, right? By the rational root theorem. So looking at that, you can list all the possible rational roots. And then it's gonna be too much time for you to check every single one by one. So please use a calculator to calculate and substitute into your equations. And check for the solutions. And you'll notice that when you plug in these values, possible solutions into this equation, you'll see that 11 over 2 is a solution to the equation. And so once you get the first solution, you can stop because you can factor it out using that solution. So once you find one root, use synthetic division to find the other factor. So you'll divide it by 11 over 2. It's the same with the constant term where the whole number, you would do the same thing. You put down the 2 and then you multiply 11 over 2 times 2 is just 11. And then you add them, 4. Then you multiply 11 over 2, 22. And so you add them, 28, multiply, and then 154. And so no remainder. Sweet. So the factored form would be 2x squared plus 4x plus 28. And and then the other factor, x minus 11 over 2. So these two factors should be equal to 0. And if you check the discriminant of this factor, it is negative. And so there are no real roots. So this is going to be the only real root, only real solution. So 11 over 2 would be your width of the container. So x is your width, and then you can solve for the other factors. X minus 2 would be the length, and then 2x minus 3 would be your height. So once you figured out the real solution, you can just substitute and figure out for the other dimensions. So we have 5.5 feet, and then 3.5 feet, and then 8 feet for your length, width, and height. Good. So now that we know how to use the rational root theorem to solve these kind of questions, let's try number 2. Try it. A jewelry box measures 2x plus 1 inches long, 2x minus 6 inches wide, and x inches tall. The volume of the box is given by the function v of x equals 4x cubed minus 10x squared minus 6x. What is the height of the box in inches if its volume is 28 inches cubed? So this is a very similar problem from the example we just did. So think about the possible values using the rational root theorem, and then you can plug it into the calculator and see if you can find just one real root, and then you can factor it out to see if you have any other real factors. And if you do have other real factors, those are other possible solutions. So you can just solve for both, okay? All right, so pause the video and see if you can do it by yourself, and come back when you're ready for answers. All right, are you ready? Yeah, so the first step, you would look at the volume. Its volume is 28 inches. So your equation should be 28 is equal to 4x cubed minus 10x squared minus 6x. And it needs to be equal to 0. Subtract 28 on both sides, and you'll get 4x cubed minus 10x squared minus 6x minus 28. And then you will look at the constant term and the leading coefficient and figure out all the possible values. We have a lot of possible values, right? Let's start with 1 over 1 plus or minus 1 over 2 plus or minus 1 over 4 plus or minus 2 over 1 plus or minus 2 over 2 plus or minus 2 over 4 plus or minus, and then what's the next one? 3? No, not 3, 4. 4 over 1 plus or minus 4 over 2 plus or minus 4 over 4, and then plus or minus 7 over 1 plus or minus 7 over 2 plus or minus 7 over 4 plus or minus 14 over 1 plus or minus 14 over 2 plus or minus 14 over 4 plus or minus 28 over 1 plus or minus 28 over 2 plus or minus 28 over 4. And then now you can check for possible solution, and you'll see that, oh, positive 7 over 2 actually works. It actually makes sense. It will make it 0. So after you get the first real root, 7 over 2, you're going to use synthetic division. So one root is 7 over 2. So x minus 7 over 2 is one factor. Now using that, you're going to use synthetic division. And so write all the coefficients, and then put 4 down, multiply, and then it's 14. And then you add, and it's 4. Then it's 14 again. And then you add again, then you multiply, and then it's 28. And then you have no remainder. Sweet. So that just means 7 over 2 is a real root. So if you find a real root, you shouldn't get a remainder. If you did get a remainder, then you need to calculate it again because maybe you made an error. Okay, and so write the factored form. 4x squared plus 4x plus 8 would be another factored form, and then you check the discriminant and you figure out it's negative. Oh, then those are imaginary solutions, so the only real root should be this one. So the height of the box in inches, which is represented by x, should be 7 over 2.